Mentioning earlier is that my name is Nirmalia Sen, and I'm an engineering director at OpsMX. A little bit about OpsMX. OpsMX provides services and products around Spinnaker. So we work with customers who in solving their continuous delivery pipelines and problems. But the topic today here is to talk about Spinnaker. And we'll get started with, talking about what is Spinnaker. So, all of you guys probably have already looked at it, and it's a continuous delivery platform. So what's continuous delivery? It's the process of taking code from check-in to all the way from testing and staging, all the security checks and all that, and finally getting into production. So all that's involved in that is termed as continuous delivery. And currently that process is quite manual, lots of handoffs between people. And so what platforms like Spinnaker allows you to do is automate that process so that you can release your software changes at a high velocity and confidence. Now, what's so special about Spinnaker? And these are my views, and that's why I love Spinnaker. And I'm working with a company that sort of specializes in Spinnaker. Is that it supports multiple cloud environments. It's not just Kubernetes or not just AWS. A lot of customer environments are not uniform. There are different types of infrastructure in customer environments. So Spinnaker supports multiple cloud environments out of the box. AWS, Azure, Google Cloud, Cloud Foundry, just to name a few, and all flavors of Kubernetes. And it has a very extensible model. So if someone wants, they can come in and add support for it. I've been seeing that, even like Alibaba Cloud, Huawei Cloud are basically being as providers in Spinnaker. The other thing it does is, it provides a single pane of control and visibility. It's not about, releasing your software with high velocity. You can actually see the resources that got deployed in the process, and you can see the status of them, and you can even control some of them. We'll take a look at briefly about some of them, like you can edit them, you can scale up, scale down, or roll back. So all that control is available to you right from the Spinnaker UI. And finally, if you want to use any such tool in an enterprise, there are lots of policies that you want to follow. It's like before it gets to production, different peoples have to sign off on it, or different testing has to be done, image scans have to be done. So you want to enforce those sort of policies, and Spinnaker has a very good flexible model to enforce those enterprise policies. So all of those make, in my view, a Spinnaker a pretty great platform for continuous delivery. So what does the Spinnaker architecture look like? It's a microservices-based architecture. That's where, the world is going. People are like refactoring monoliths to microservices because it's easier to manage them. And Spinnaker is no different. It consists of a lot of microservices. I'll not get into the details of all of them because this architecture discussion can be a session by itself. But I'll point out a few of these things. Is the UI that we look at is handled by DEC, and then this gate is like an API server. The UI uses it, or if you're using APIs, that's also interacts with gate. The main workhorse is really this cloud driver that actually talks to the different providers like Kubernetes or AWS and does the work. And this Orca is sort of the orchestration engine in there. The reason it's good to know about this component is that, if something goes wrong and you have to look at the logs, you know where to go look at the logs for, right? And the other thing that is there is that whole thing is configured and controlled through this component called Halyard, which runs on the side, and it can be used to configure and manage the whole Spinnaker deployment. Let's go into how you can install Spinnaker. So there are different installation options for Spinnaker. Like we saw just now, it's a microservices-based architecture. So the best deployment option for Spinnaker is to deploy in some Kubernetes environment. And that's the recommended way to deploy for production usage, because you can scale different components, manage different components easily. There are published images from the community for Spinnaker. There's a pretty regular cadence of new releases coming out lately. Some people, enterprises, want secure images. So there are even UBI 8 based images that are available. And to deploy it, the community provides a Helm chart using which you can install Spinnaker. And you'll see, I'll actually use the Helm chart to install one in Kubernetes environment. There's also an operator available to install it. And specifically, if you're an OpenShift shop, you can go to the OpenShift marketplace, which is available in the 4x versions of OpenShift. And you will find the operator there and use it to install Spinnaker. With that said, if you have a VM, you can definitely do a single node installation of Spinnaker on that VM. I know at least one of our customers use that, and they deploy a multi-cluster or multi-node deployment of Spinnaker on VMs itself. It can be done. It's a little complex. You have to bring up Spinnaker on different machines and then say what runs, and then have to tell sort of how they communicate with each other. So it's possible to do it, but your life's made a lot easier and simpler if you just deploy and manage it in a Kubernetes environment. And finally, if you want to develop on it, enhance it, improve on it, you can do a local installation from GitHub. So going into how to install Spinnaker in Kubernetes. Really, if you want to do something serious with Spinnaker, you need to make sure you have at least 20 gig of memory and 6 cores available. If you just want to kick the tires and see how it works, you could do with less memory and CPU cores, but anything serious, I think 20 gig and 6 core is what you should allocate. And the thing that you need to also make sure is that you have support for persistent storage in your Kubernetes cluster. Like if you're using something like Minikube and all to play around, if that's your Kubernetes cluster, make sure you have persistent volume set up so that your deployment goes through and works successfully. Optionally, you can customize your deployment. Once I install, I will actually walk you guys a little bit through the Spinnaker values.yaml. There's a lot of customization you can do, and I'll just cover some of the very basic ones and not get into a lot of the detailed ones. And finally, once you have that and you have Helm available and ready to go, it's as simple as a command Helm install Spinnaker and stable Spinnaker, and it will install it. And within like 7-8 minutes, you should have a running Spinnaker. So let's go set one up. So I have a Kubernetes cluster set up over here. I've set it up with 6 nodes with some 12 CPU cores and 45 GB of memory. And I have a Cloud Shell that actually is configured to talk to it. I'm hoping the font size is right here and visible. So if I look at kubectl, get nodes, oh, I misspelled that. And let's make sure this talks, it shows up the 6 nodes I have. And I have Helm already installed here. I have Helm 3.2.4 already installed over here. So if I look at over here, I have a values.yaml here already in there, and I'll walk you through that. So let me just kick off this install with the command that I just showed to you, which is helm install Spinnaker stable Spinnaker. Okay, let that run. While it's working, let me open up another sort of a shell. And let me increase the font here. And we'll look at the values.yaml here. You configure different aspects of the YAML. Is this, it has a black background, I know, so hopefully it's visible. I'll just make the font a little bigger here. So things that...
It's a bit visible.
It's a bit visible, okay.
It's navy blue on black, so it's a little challenging, but it's a little bit visible. Yeah, that's better.
Okay, okay. Things that you can configure is the version of Spinnaker you want to install, right? This one is going to install 123. You could also update and configure the halyard. Remember the configuration item that I showed in the architecture side on the right-hand side? You can configure the image to use and the version of the image to use. If you don't have persistence, you can turn it off by using this flag to false, but you know, hopefully all of you are getting the idea that without persistence, if the cluster goes away and you come back up, you have lost all your data, right? So, so in case you don't have it, you can turn it off and use it. So there are a lot of other configurations that you can do. As you get familiar with Spinnaker, you will understand and be able to do it. What I also wanted to point out is that persistence is at a couple of other places. This Spinnaker uses Redis to store some data and a storage, which could be Minio locally or even could be external sources, which I'll cover right once I get back to the slide. And so if you want to turn persistence off there, you know, you can uncomment these lines over here that will turn persistence off for Minio and Redis that is used. Other than that, there's, as you can see, there's a lot of configuration that you can change here. You know, that's for an advanced session, which I'll not get in here. Just to point out that, you know, this is highly customizable. So it has triggered off the installation over here. It's going on. If I can go in here and look at the workloads, it is basically coming up. It's triggered off the halyard, which I was talking about, and it's bringing up all the other things. Now, you see what it's telling you is that to access Spinnaker, you expose the deck and the gate pod, right? That works very well when you have a local system testing it, right? But if you want to expose it to the world, you need to provide an ingress or a load balancer access to it, right? And that's exactly what I'm going to do to access my Spinnaker. So I have a file here called spinservices.yaml. I'm going to highlight this thing a little bit here and make the font also a little bit bigger. So you can see over here is that I'm creating a service of the type load balancer. Luckily, you know, Google Cloud GKE would provide one with an external IP access. And it's pointing to the deck. So that's what I'm going to do, is basically create a service to access my Spinnaker. So I'm going to do a kubectl apply -f that file spin services. So it's going to create that workload. So it will take 5-6 minutes to come up. Actually, these are all up. And this my ingress is, or the load balance is getting created. So let's go and talk about a few of the Spinnaker artifacts and objects, and then we'll come back here and look at Spinnaker UI, okay? So we just set it up. So let's look at what are the different Spinnaker objects that we should be aware of. First of all is the storage provider. You know, we talked about this persistent volume, right? Saving it so that it's available and you don't lose data. So all your configuration and pipeline information is stored. You can store it in some sort of a object store. It could be your Google storage, AWS S3, Azure, or default out of the box, you can use Minio. So that's what's configured to use. Spinnaker also uses Redis to store some of the runtime data. And if you want more performance or the data to be persisted, even because some of that runtime data you want to look at it and analyze and run some audit on them, you could even use MySQL for that. And I showed you that we configure Minio over there. So you configure them in values.yaml, but you can even change them later on in the Halyard too. So that's one of the objects that Spinnaker uses to store data. The next is the most important one, is the cloud providers. That's basically the workhorse for Spinnaker, right? If you are deploying to Kubernetes or Google Cloud or Azure, AWS, all these are first-class support built into Spinnaker. And this is just a small list. If you can go and look at the cloud driver, or even if you look at HAL config provider, I'll show you a little bit how to get there and run some of these commands once it's up. But you can look at the list of different providers that are available out of the box for you to use. And they basically abstract out the underlying concepts and make it available to you in Spinnaker for you to configure and manage. Next is continuous integration with continuous integration systems, right? Continuous integration, basically check-in and building and doing regression testing, has been going on for decades, and it's a pretty mature area. And Spinnaker doesn't require you to redo those and into the Spinnaker world. Spinnaker provides direct integrations with your existing CI system, be it Jenkins, Travis CI, Wrecker, or Concourse, Google Cloud Build. It provides integration with them. So from your Spinnaker pipeline, you can trigger some of these things. And it's pretty much a two-way integration, in the sense is that not only can you trigger, say, a Jenkins job from Spinnaker, on the completion of a Jenkins job, you can trigger off a Spinnaker pipeline, right? So if you have a well-established CI system, you can basically, from that point onwards, start your delivery pipeline in Spinnaker. So that's there. That's what these first-class integrations with these CI systems provide. Next is the artifacts. Any pipeline, or any of your development process, you are dealing with Docker images or Helm charts, or AWS images, Google images, or jar files in a Maven repository, or GitHub files. So all those things are available. All those external resources are available in Spinnaker for you to access and manipulate them or use them in different stages. They're identified in Spinnaker by their type. like it's a Docker image or a GCS object or an S3 object. And you have an URI to reference them and credentials to access the artifact. And then any other detail to more define the artifact. And so this is basically also another crux of Spinnaker, where you have a Jenkins build that's generating a jar file that's stored in Maven, or generating a Docker image that's stored in your Docker repo. So you can basically pass them in as artifacts and use them in your stages to deploy or to build and basically run your whole pipeline. Right? So those are the different artifacts that you use and configure. Let's go and look at Spinnaker. So what we'll go and look at is look at our Spinnaker. We'll walk through some of the functionality within Spinnaker and how you control them. Okay. So let's see if our access is ready. So let's refresh this. Hopefully it gave me an external IP. Yes, it did. So I have Spinnaker now available and an external IP address. So let's click on this link. Google does this redirect. And there you go. I have my Spinnaker up and available. Before I go into Spinnaker here, you know, we were talking about Halyard, where you run those HAL commands. Remember all the screens I was showing you? There were these commands that you can run to configure each of them. How do you do that? So that is running in this pod called Halyard. So if I do a kubectl get pods, you will see a bunch of pods that are running. And one of them is this Halyard pod. So I can exit into that pod. And, you know, I can run all the HAL commands here. So HAL version. And, you know, I can basically see all the different commands that I can run here. So some of the commands we were looking at, say HAL, let's look at one of the commands we were talking about, was HAL config CI, right? I can do a HAL config CI. It will tell me all the HAL commands that I can do. So here I can manage Tracker, Wrecker, Travis, Jenkins, Google Cloud Build, Concourse, Code Build. Code Build is new. I think it came in, I think, recently. I don't think I saw that before. So that's how you do it. And this is very useful. Say you want to use Jenkins, you basically run Jenkins. It will give you all the subcommands available under Jenkins. So there's no Jenkins really configured in here. So you can do actually a -- helps to see the command available. So you can enable it, disable it, add a master for continuous integration. So, you know, so that is how you run the HAL commands. Get onto the Halyard pod and, you know, run the HAL commands to configure your system. With that, let's get into Spinnaker UI. So this is the Spinnaker that we just set up. So what does it have? It has applications. Applications are, you know, things that you build as an organization that your end users use, like a marketing applications, a sales applications, a shopping cart as an application. So you can create new applications here. So I'm going to just create an application which I'm going to call demo. And looks like there is an application already demo in there. So let me create another one called demo Spinnaker. And did I get something wrong? Okay. Let's give the email address as demo@example.org. And let's create it. Now, so it has basically created the shell for this applications. What do we have here? So what an app the view over here is basically, it's a collection, or you can think about it as an inventory of all the resources that make up your applications, right? You have clusters, which are like, servers, could be Kubernetes deployments, or AWS EC2 instances, or ECS clusters. So all those clusters are available here for you to see. Your load balancers, the way to access your services, and then if you have defined any firewalls and all that. And if you actually had been using Lambda functions and all that, which you can use, there would have been another tab here showing up here as functions. Here, if you had an account, the different accounts, and here an account is a resource, infrastructure resource that you use, like a Kubernetes account or an AWS account. So if your application is using multiple accounts, they show up here. And so you can get to see a lot of different sort of aspects of your infrastructure right from here, which is basically, like I said, is an inventory of your application resources, right? Now, how do I create these resources? You could always create them right from here manually, but the ideal way to do it is basically through pipelines. That's what you do. Today, we'll just go ahead and create a very simple pipeline. Let's call it our demo pipeline. So when you have a pipeline, there are a lot of things you can configure in a pipeline. You can have automated triggers that you can add to a pipeline. You can say the pipeline gets triggered even as a cron job, like run this every day at 9 o'clock. Such pipelines are used by some of our customers, like, at 9 o'clock people would come in and you want to scale up some of the resources. You can have a cron job that runs at 9 o'clock every day, or 8:45 before people come in at night, and scale up the resources. And then again, another at 6:30 to scale them down. Like we're talking about, they can come to Jenkins jobs, or someone has checked something into a Git. Those could trigger the running of these pipelines. Also, you can have parameters defined in a pipeline. That's what makes it basically templatized, if you can say. You can use the same pipeline across teams, or use pipelines to deploy to different namespaces in Kubernetes, or to different environments like stage, UAT, or stage 2. Or say you want to deploy to US East versus US West. You can have parameters to drive all of those things. Now for us, we're not going to add any trigger, or we are going to add any parameters. So I just deleted them. I just want to keep it simple. The other thing is that you can have a lot of notifications. Email, integrations with Slack, Google Chat, all that can be integrated and get people notified when a pipeline is starting, completed, or failed. And we'll see that as we add more stages, you can actually have notifications and controls in different stages too, right? So at a pipeline level, there's a lot of configurations that you can do. Let's add a simple stage here. What we are going to do here is just deploy a simple manifest that will deploy Nginx server and create a service to access it, okay? So we basically have a stage added. You can see there's a lot of inbuilt stages available, like a wait stage that will just wait for some time. You can undo it. You can run a script. You can scale, save pipelines, run another pipeline. So you can have nested pipelines. So you can have an Uber pipeline that's invoking other child pipelines. You can have manual judgment stages. Well, let's add one, a manual judgment stage, where someone can review the results, and then they decide if it should move on, or you should abort the pipeline, right? So we will add one more stage here. Look at other options in there. So you can run a Jenkins job like I talked about. What we are going to do is deploy a manifest, right? So like I said, we're going to deploy Nginx server. Now this manifest can come from, say, a GitHub, like you have saved your manifest in GitHub and all that. So you could actually have the manifest come from GitHub or Artifactory and all that sources. For our case, we'll just type in the manifest here. I have a simple manifest that I'm going to pick up. Oh, I'm in the Helm chart here, so let me go in there. Let me just copy this in there and I'll quickly walk you through that over there. Okay, so you can see it's a simple deployment that's deploying. I'll just make it one instance of Nginx 7.0 being deployed, running on port 80, and then I'll just create a service to access that, right? Let me save the changes. And let's talk about a few other things. There's a lot you can do here with the stages. You can run them in parallel. Like if I say here, so let's say add a new stage called test. And I say, oh no, what happened here? Oh, I didn't select the type. Deploy manifest. Let's say I want to deploy another manifest. And I say this depends on the previous manifest. Or let's say I want to make it deploy on the first manifest. Oops, sorry. What I wanted to say was deploy on the manual judgment. So once someone approves it, I want both these deployments to run in parallel. So I could do that. So I can run them in serially, in parallel. So I can do a lot of permutation combinations or however I want to design my pipeline, I could do that, right? So let's get out of this and try to run the simple pipeline that I created that has a manual judgment and then deploys a manifest, okay? Let's go back here. There is my pipeline and I'm going to do a manual run of that pipeline. And I say run. So this has triggered off running of the pipeline. Like we talked about, it is now waiting for someone to take some action. Someone can go review stuff, and if they don't like it, they say stop it. It will stop the pipeline. But in this case, we want to go ahead and deploy. So we'll say continue. This will trigger off deployment of the Nginx server we talked about. The good thing about this is that you can monitor the progress as it's going on. It will show you the YAML for the service that's going to get deployed. You can look at this over here. Now you remember our annotation or the manifest was very simple, but you will notice Spinnaker adds a lot of metadata annotations to it because it wants to manage it. You can scale out, roll back, and all that it does via this manifest it adds additionally. Okay, you can look at the task status, you know, what are the different things it did in the whole process. It deployed the manifest, it refreshed its cache, and made sure the service is up and running and got everything available, right? We can see here it completed. So let's go look at the infrastructure here to see if we see our service there. There you see, we have our deployment right there. This is the deployment that we made. And this is the pod, that single pod that we wanted to bring up. It's running. We can see the output of that pod right from here without having to go into kubectl, making sure I have the right kubeconfig file and access it. I can just look at the output right from here. There's no output in there, so it's empty. But this is very useful when you have, say, a pod that's not healthy. It's red. Then you need to go in there and look at what's going on. So instead of giving your end users or developers direct access to your stage or prod environment, they can come in here and, within the confines of this, they can look at the logs and figure out what's going wrong here, right? I can take actions on the pod, right? I can make edits to the pods right here. I see the YAMLs in here. I can save them. We'll do some of that. We'll go to the deployment. And what I'm going to do is we're going to scale it out. Without going anywhere, right from here, I can scale this out from 1 to 2. After given the account name as a safety. So let me submit this. It's actually started deploying it, okay? And very soon we'll see the second node show up here. I'm going to close this while I show you some other things here. We created a service, right? So I can go in here and I look at the service that it got created. So using this, I can access this NGINX, right? So it shows me the ingress, internal IP, and the ingress URL to access. So I can click on this, and there you go. I have access to the NGINX server that I deployed and is available to me, right? If I go back here, I scaled it out. And there now I have my 2 NGINX servers available to me. So, suddenly I see load going up, just like, editing right here, I can scale out my number of nodes to 3 to handle it. It's done. And let me just go scale it back down. I can go to scale it and reduce it down to 1. It will go ahead and actually refresh the cache and show me that, it went away. So this is what I meant earlier when we talked about Spinnaker allows you to not only have visibility, but also control, right? So as you can see here I have a pipeline from where I had gone ahead and deployed my infrastructure things. So it's managing the delivery of my resources, right? While when I come to the infrastructure tab, I'm able to manage that infrastructure. I can see what's going on, what's their status, and I can act on them. I can go ahead and delete them. I can go ahead and, why is this thing? Okay. I can go ahead and scale them out. I can edit them, make some changes right here in the YAML and deploy them. I can do all of that control right from here. Now, here I was showing you for Kubernetes. I could do the same thing for AWS resources too. I could do the same thing for Azure resources too. So, from the same UI, I can control resources in multiple accounts. There's also a lot of good, strong RBAC built in, which can control who gets to deploy in different environments. I don't have a demo for it, but things like only developers can deploy to stage environments, but only ops people can promote to, say, production environment. So you can have controls like that, is that only users in a certain group have access to the production account. And if a developer is running the pipeline, they cannot execute that pipeline. So that sort of, in a very brief, covers sort of the Spinnaker features. Let's walk through. I walked you guys through, applications in Spinnaker. I walked you through clusters in Spinnaker, which are like, as I say, an inventory of resources in an application. We talked about pipelines, what are the different configurations in pipelines. We talked about the pipeline stages, and we talked about pipeline trigger that you can do from the configuration stage, where you can have a GitHub trigger or a Jenkins job completion trigger the pipelines. With that, let's, I'm not going to get into the details of it, but let's even talk about, any enterprise deployment is not complete without securing your environment. And Spinnaker provides pretty strong mechanisms to secure it. You can enable SSL for your environments. So you can SSL enable both the UI front end as well as the API front end. And there are commands to do that. Then you can enable authentication. Right now, I just went into the URL. There's no authentication, right? So you can enable authentication, and the supported methods are LDAP, OAuth2, SAML, or X509 certificates. So those are supported out of the box. And you can also enable authorizations, where the providers can come from LDAP groups, Active Directory, SAML, Google Groups, or even you can use GitHub Teams to control authorizations. And like it's mentioned here, you can use it to control who has access to what applications, what accounts, and pipeline executions. Like you may have a pipeline that deploys to production, but you want only the ops people or persons to be able to execute those pipelines. Others can view that pipeline, but they cannot execute it. So you can control, or you have such fine-grained controls in deploying. With that, I sort of have covered what I wanted to cover about basics of Spinnaker, which is what is Spinnaker, what are the different types of objects that Spinnaker allows you to control, how to install it in a Kubernetes environment. So it's very simple, less than 10 minutes. I had a Spinnaker up and running and I was playing with it. And we walked through the features in Spinnaker. With that, I would open it up for any questions or any comments that you guys may have.
Okay, so I've got 3 questions in the Q&A, and then I'm also going to start allowing folks to talk. So let me just address those questions in the Q&A first, and then folks can unmute themselves and ask questions. So here we go. Okay, so the first question is it possible, once it has been bootstrapped, to have Spinnaker deploy and update itself?
That's a very interesting thing. So in our lab or environments, what we do is we use Spinnaker to update other Spinnakers. So basically what we have is we have a Uber or a master Spinnaker that we use to update other Spinnakers. So absolutely that's what you can do. Not update itself per se, but use a Spinnaker to update other Spinnakers.
Okay. And is it possible to define your pipelines in code and load them from a Git repo?
Yes, absolutely. And let me talk about that a little bit and go into the demo. I guess my screen is still being shared. Yes.
Yes.
Everything in Spinnaker is code, right? So, we saw this pipeline. This whole pipeline is actually stored and managed as a JSON file, right? So this is the JSON file of it. So you could absolutely manage this in Git and have these synced whenever Git changes, have these pipelines get updated. So yes, you can have this as code and manage through Git. Now, another thing which I did not cover is really an advanced topic is this pipeline templates. So what you can have is you can have pipeline templates created out of your pipeline. So any new developer or a group coming in, they can create the pipelines out of that pipeline template. And what it does, it's really a template. It does not make a copy of the pipeline. So your actual pipeline references the pipeline template, which is, again, like I showed, is a JSON file. and it has parameters and all that. So when you change your pipeline template, all the pipelines that were derived from the pipeline template inherit them. What it means is that suppose you want to introduce a new, say, security scan stage in your pipeline. You update your pipeline template. All the pipelines that inherited from that would get that security scan stage. So that's another good way to even enforce uniformity across different pipelines.
Okay, and the last question from the Q&A is, what does Spinnaker do that Jenkins cannot do? I see this is creating pipelines similar to Jenkins.
Sure. Like I think I said in the beginning, is that Jenkins is traditionally used for continuous integrations, and you should absolutely continue to do that. A lot of the things that what I showed you could do with Spinnaker, like scaling out, rollback, and all that, you could absolutely do in Jenkins, but you have to write code for that. There's no first-class support in Jenkins for that, right? So absolutely you can do that in Jenkins. But what Spinnaker provides is providing first-class support for some of those things in the UI. It supports rollback strategies, which is very important when you're doing continuous deployment, right? You have to write code in Jenkins to do that. Say you're rolling out something and you find out that there's an issue with the rollout in production and you want to roll it back. And you want to do that in an automated way. So there's different deployment strategies like blue-green, or some people call it red-black. So you can employ that, and Spinnaker would automatically handle that. Those basically are provided as first-class support. So some of those features which are inbuilt into Spinnaker makes Spinnaker sort of unique in continuous delivery. Can you do them in Jenkins? Absolutely you can, but you have to write code with it. And also, as I mentioned earlier, Spinnaker doesn't replace Jenkins. I think it just helps you improve the continuous delivery process to deploy faster and better.
Okay, if there are any more questions, you guys are welcome to unmute and go ahead and ask them. Oh wait, is there another one? Yeah. Okay, so we've got another one. How is Spinnaker different from CD tools like Tecton?
So Tecton is purely focused on Kubernetes. So it basically manages Kubernetes manifests and manages that very well. It's a choice that you have to make. If Tecton does your work, sure, but it's purely focused on Kubernetes. Whereas if you want to have multi-cloud support, where you are using it to manage AWS resources, Lambda functions, ECS resources, along with Kubernetes or Cloud Foundry, that's where Spinnaker comes into play. Also, not sure if Tecton has some of these things like manual judgment, stages and all that, typical in the workflow. A process, if it's there in Tecton, so then there's feature parity, but otherwise, you know, this multi-cloud support is definitely a feature that makes Spinnaker different than Tecton.
Okay, any more questions? I don't have anything else via the Q&A channel, but you guys are welcome to unmute and just ask directly too. And if you're having issues with that, just ping it. Okay. Nirmalai, thank you so much for coming on and teaching us about Spinnaker Basics. Oh, looks like there was one there, sorry. Could you speak a bit more about storing pipelines in Git? Is that a pipeline stage?
No, it's not a pipeline stage. What you could definitely do is that if your Git changes, you could have another pipeline that can trigger an update, say your pull in the pipelines from Git and put it into, say, you are using Minio or S3 and move the pipelines into that storage. And that would be reflected back in Spinnaker immediately. Yes, you can build a pipeline to manage the pipelines from Git into Spinnaker. It's either a pipeline within the same Spinnaker itself or a separate Spinnaker.
Okay, any more questions, folks?
Hello.
Hello, hi, who's speaking?
Hello. Hi, this is Bala here. I have a quick question to you, Nirmyan. Is it possible to run the Spinnaker in an on-prem solution and then monitor the, do the deployments in the Kubernetes present in AWS or another private cloud? Can we do such kind of hybrid solution?
Absolutely, yes. Actually, that is another great question. And some people ask is that, do I need a Spinnaker for each instance? No. You could have one Spinnaker that you can use to manage multiple resources, multiple Kubernetes resources, be them on-prem or in the cloud. Only requirement really is there be able to connect to that Kubernetes resource from where Spinnaker is running, right? So that's really the only requirement. Otherwise, you can use a single Spinnaker to manage multiple Kubernetes environments, or use the same Spinnaker to manage AWS, Azure, Google resources. So absolutely, you can share a Spinnaker to manage multiple environments.
Okay, thank you.
Okay, any more questions? Well, thank you so much, Nirmalai. I really appreciate your time and coming on and being part of the CDF community. We hope to see more from OpsMX about Spinnaker. And if folks don't know, we do have the call for papers open for CDCon, which is happening October. It's a virtual event, so we are taking talks. We'd love to see more of our Spinnaker community represented. We also have an ambassador program, if you are not aware. We'd love to also see more Spinnaker folks there. So let me know. There's a few ways to get involved. And yeah, we're doing these webinars as often as we can. So hope to see you again soon.
And thank you very much for hosting me. It was a pleasure talking over here. Thank you.
Awesome. Great. Have a great day, everyone. Thank you so much.
Have a great day, everyone.